Suppose we have three connected ramps in such a way that the first ramp and the third ramp are inclined at a certain angle. Imagine that we let a ball slide from the first ramp. What will happen? Well, we think the same. Obviously, after sliding down from the first ramp, the ball will follow a straight path with respect to the second ramp until it eventually climbs up with a height that is the same as the initial height. Now, what if we remove ramp number 3? What will happen? Of course, if something will not let the ball stop, the ball will move to infinity and it will move forever. This is exactly the Galileo's concept of inertia. It says that an object in a state of motion possesses an inertia that causes it to remain in that state of motion unless acted by an external force. As we know, inertia is the property by which objects resist changes in motion. And we always experience this in our daily basis. Just imagine that you are riding in a bus that accelerates or that moves at 50 kilometers per hour. And then suddenly, the bus slows down. What will happen? We can just imagine that our body tends to resist the slowing down of the bus. If we could just imagine that if initially the bus is moving towards the right, and then suddenly it moves towards the left, we can feel that our body resists moving towards the left. That property is within ourselves. That property is what we call as inertia. At the age of 23, Sir Isaac Newton has reformulated or has generalized this Galileo's concept of inertia. He formulated his Newton's third law, or the Newton's three laws of motion. And these three laws of motion have completely overthrown the Aristotelian concept of motion. In the Newton's first law of motion, it says that an object at rest or in motion remains at rest or in motion unless acted by an external force. But what exactly is an external force? Suppose we have a box that lies at the surface of the floor. If we want this box to move, of course we have to apply a force. In its simplest sense, a force is a push or a pull. So if you push this box or if you pull this box, the box will of course have a motion. But in a general sense, there are actually so many external forces that are present in nature, some of which are the friction forces. As we know, a friction force is a resistive force that opposes the motion or attempted motion with which it's in contact. And this is also applicable in fluids. We have the air resistance and so on. So really, this Newton's law of inertia is very important for us to understand. There are certain mathematical formulations of this Newton's first law of motion. There are certain mathematical equations that best describe this Newton's law of motion. So if you have questions or clarifications, you may just type your comments in the comment section. Thank you very much.